For any business, trying to predict the future is one of the biggest challenges there is. How much inventory should you stock? How many people do you need on staff next week? Getting that forecast right is absolutely crucial. But how do you actually do it? How do you put a number on what's coming next? Right? It can feel like you need some kind of crystal ball to figure this stuff out. But here's the thing. It's really less about magic and much more about math. It's a puzzle, and it's one we can actually solve by looking backward to see what's ahead. So let's start at the very beginning. The simplest idea of all, using data from the past to make an educated guess about the future. We're going to use a real-world example to see how this works. And, well, where it can go wrong. All right, check this out. This is weekly sales data from a company called WFJ Sales. Our mission, should we choose to accept it, is to predict their sales for the coming weeks. We've got all this history, so where do we even begin? Well, the most basic, you might even say naive approach, is to just throw all the data we have into a big pot and stir. In other words, we're just going to calculate the average of all the historical sales numbers. It's simple, for sure. It's fast. But is it any good? So you crunch the numbers for the first 26 weeks. And what do you get? You get 30,102. So our forecast for every single week in the future is 30,102. But as you're about to see, this forecast has a really big problem. And here is the issue. Our forecast is stuck at 30,102. But just look at the recent sales. They've been trending way higher than that. A simple average gives the same importance to sales from 6 months ago as it does to sales from last week. Our forecast is literally being dragged down by old, irrelevant data. Okay, so clearly we need a smarter way to do this. We need an approach that gives more weight, more importance to what's been happening lately. And that brings us to our next method. This is where the moving average comes in. It's a really clever idea. Instead of averaging everything, we only average the most recent data, say the last 3 weeks, or maybe the last 7 weeks. And as a new week's data comes in, we drop the oldest week from our math. Think of it like a window that's always sliding forward in time. So how does this actually work? Well, a 3-week moving average is super simple. You just take the sales numbers from the last 3 weeks, add them up, and divide by 3. That's it. As the next week's data rolls in, your little 3-week window just slides one step forward. But this is where things get really interesting, because now you have a choice to make. A short-term average, like 3 weeks, is going to react really quickly to any changes. It's nimble, but it can also be pretty jumpy. A longer-term one, like 7 weeks, gives you a much smoother, more stable forecast, but it's going to be a lot slower to adapt when things really do change. So, which one do you pick? And here's the catch with moving averages. They've got a couple of problems. First, old data gets dropped so abruptly. I mean, 1 week a sales figure is super important, and the next week, poof, it's gone, as if it never happened. Second, you have to store all that past data just to keep doing the calculation. It feels a bit clunky, inefficient. There's got to be a more elegant way. And there is. It's called simple exponential smoothing, or SES for short. And it's a beautifully elegant solution that fixes these problems by creating a weighted average, where old data just kind of gradually fades away into the background. The logic behind SES is actually incredibly simple. We are constantly updating our forecast based on how wrong we were the last time. Each brand new forecast is just a mix, a blend of two things: the real number that just came in and the forecast we made right before that. So how do we do that blending? It all comes down to this one little parameter called alpha. And you can think of alpha as a trust knob. If you crank that knob up high, you're saying, I trust the newest piece of data a whole lot. If you turn it down low, you're saying, nah, I'm going to trust my stable old forecast a little more. Finding that perfect spot for your trust knob is the key to a great forecast. And this is the magic formula, but in its most intuitive form. Your next forecast is simply your last forecast, plus a small correction based on how wrong you were. That forecast error is just a fancy way of saying, what was the difference between what I predicted and what actually happened? We are literally learning from our mistakes, period after period. It's brilliant. Okay, so simple exponential smoothing is pretty great, right? But it has an Achilles heel. What happens when your sales aren't just bouncing around an average, but they're consistently growing or declining? Well, that's a trend, and that's a whole new challenge. So take a look at this sales data. I mean, it is clearly trending up and to the right. But when we apply our trusty simple exponential smoothing model to it, our forecast is just a flat line that is always lagging behind reality. It's constantly playing catch up, always one step behind. So what gives? Why did it fail so badly here? Well, the reason is baked right into its DNA. Simple exponential smoothing is designed to find and predict a stable average, a local level. It has no concept of a trend. It's always assuming things will eventually come back to the mean, but in a growing business like this one, they just don't. So we need an upgrade. We need to call in the cavalry, and that cavalry is called linear exponential smoothing, also known as Holt's method. It's a more powerful version that forecasts two things at once, the level, like before, and now the trend. It's built specifically for data that's on the move. And here is the payoff. When we use linear exponential smoothing on that same data, look at that difference. It is night and day. The forecast is no longer a sad, flat line. It's a sloped line that actually captures the upward momentum of the sales. Now this is a forecast we can actually use. So we've gone on a pretty cool journey, right? From simple averages all the way to these sophisticated trend models. But beyond any one specific method, there are some timeless principles, some sage's wisdom that apply to any forecasting you ever do. So let's wrap up by looking at these big ideas. All these principles really share a common theme. First things first, always look at your data before you do anything else. Plot it out, see what it looks like, and clean up any weirdness. Then, and this is so important, keep your methods as simple as you possibly can. And finally, remember this. Forecasting is not a one-and-done thing. You have to keep testing and updating your model as new data comes in. It's a continuous process. Look, if you take just one thing away from all of this today, let it be this. There is no single best forecasting method. There just isn't. The best method is always the one that matches the patterns in your data. You have to understand your data first, and only then should you choose your tool. We've learned how to build these amazing models that can see patterns in the past and project them into the future. But that leaves us with one last, really challenging question. These methods are great for forecasting the data we have. But how do we even begin to forecast the truly unpredictable, the sudden shocks, the black swan events that no amount of history could ever prepare us for? Now, that's a question to keep you thinking.